Hey, Jack Doyle here. I'm going to explain this new ThroProps plugin, which I'm very excited about. I'll show you some code samples, I'll show you what we can do, and I think you're going to like it. To start off with, let me crack open this Plugin Explorer, which is in all the downloads for the tweening platform. It's also embedded on the web pages. And if you scroll down to ThroProps and then click on Example, and you'll see what it can do here. You can click and drag and flick this just like on the iPhone or the iPad, where you can flick as fast as you want, and it'll continue that motion for you, and then it will impose limitations as well, so that you can't drag past the very end of the content, or you can't flick past there. And if you do get it going with enough velocity, then it'll shoot past that, but then nicely ease back into place. And of course you can, it's not just for Y movement, you can do both X and Y. And it's not even just for X and Y, it can do things like rotational values. It can do any property, any numeric property of any object. So here's an example of messing with the rotation property. You see, the fundamental problem this solves is that sometimes you know the velocity at which you want it to start, but you don't really know the end value. So in this case, let's say we want to start box 1 animating across the x-axis at 200 pixels per second, just to begin with. And then over the course of 5 seconds, it will gradually come to a stop using the quad ease out easing equation. So there you go. It makes it to, around here, but we didn't have to plug in that end value. And if we want to change the velocity to, 300, then it goes further across the screen. And if you want to reduce the duration of the tween, then again it adjusts the end value where it lands. And so we can also add other properties here, like let's say we're going to give the Y property a -30 velocity. Let's keep this at 4 and 200 there. Alright, and then what if we want to change the ease to a strong ease out, which is a much more aggressive ease, so it'll slow things down faster, so you didn't go nearly as far. So we can beef up the duration to 8 seconds, and see now it starts to go further. But what if we want to impose some limitations? Or if we want to, let's say that this dot on the screen, which incidentally has the instance name of dot, let's say we want to have box 1 start out at a x velocity of 200 and y of -30, but we actually want it to land exactly on that dot. And by the way, the registration point of box 1 is right in the center of it. So if we want to get fancy like that, we no longer just pass in a number. We create an object here, and we'll say velocity is 200, and then we can set a max and a min. So if we want it to land exactly on a spot, then we can make both the max and the min the same value. So in this case, we'll just say dot x, and then the min is dot x. Again, make it a match, and then we'll do the same for y. We'll say velocity is -30, max is dot y, and then the min, scroll over here, it's going to be dot y. So it lands exactly on top of that dot. And it doesn't matter if we beef up the velocity to crazy amounts like 1000, and then we'll say, -100. Doesn't matter. It'll shoot past and it'll ease nicely back into right on top of that dot. So it's easier to see the smoothness of the, or verify that it's moving at the correct velocity if we do something a little different here. We've got some other tweens that are created down here already. So all it is we're going to tween box 1 and box 2 over the course of 2 seconds. And this is a relative tween. Notice that it's in quotations here. So whenever you pass in a string as the value, TweenLite and TweenMax interpret that as a relative value. So it's going to tween it box 1 and box 2, 400 pixels to the right, using a linear ease. So we know that that's going to be moving at exactly 200 pixels per second. And then at the end, when each one completes, they're going to call these methods. And then we're going to do a 4-second tween. And since again we know the velocity, we plugged it in here. If I comment these out, you'll see that the initial tweens just kind of come to a screeching halt. But this makes them go nice and smooth and ease out. So now that we have both of the boxes animating in the same way, let's alter one of them and then we can see how they compare. So let's apply a max value to this box 1 tween. Velocity is 200 still. And then we'll do a max of that dot's X position. And then when we publish, you'll see that it still honors that initial velocity forwards, but then it adjusts it smoothly and eases it back into place where it should be. So I can move that dot wherever I want, and it should still look relatively smooth. Alright, great. So there's still one more problem. Actually, a few more problems. What if we don't know the duration that we should make the tween? In this case, they're both 4 seconds, and we can change the velocity and that'll make things go further, and we can change the ease and all that. But what if we want to apply a common resistance value? So for example, if box 1 is moving at 1,000 pixels per second and box 2 is only starting out at 200 pixels per second, well, box 1 would naturally, the tween would take longer because the initial velocity is so much higher, it would take longer to come to rest compared to box 2. So how do we figure out the duration? Well, don't worry, ThrowPropsPlugin has some built-in static methods that take care of all that for you. So let me show you what that looks like. We'll get our 2 tweens going here for box 1 and box 2. We'll make them identical. Alright, but if the goal is to not have to define a duration, then we're going to tap into the ThrowPropsPlugin.to method. It's identical to the TweenLite.to, but we don't have to define a duration. So if I publish this, you'll see it still works. It figured out that it's going to use a 2-second duration because the whole calculation is based on a resistance factor, and there's a default resistance. And so we can change that by doing something like this. Let's give it less resistance. We'll do half the amount of resistance. And so this should cause them to last a little bit longer, and they do. And let's say that we want to, let's increase the initial velocity for both of these. But on box 1, let's define a different resistance value. We'll say that this is going to be a lot more resistance. And so you'll see box 2 flies away. Box 1 had more resistance, so it stopped sooner. So let's check the duration of these. This method returns a tween, just like TweenLite.to, so we can store that in a variable. And we'll do the same thing for tween 2. And the goal is to, we're gonna trace out the values. Alright, so we'll publish it, and we'll see that indeed the first tween is 2.5 seconds, the second one is 10 seconds. Alright, so if we want to put a cap on these, there's going to be situations like in the flick scrolling example, where the user's mouse could be moving really, really fast. Let's say that this is going to be moving at a crazy a speed like 10,000, and at a resistance of 200, let's just see what kind of a duration that gives us. 50. Now we don't want a 50-second tween. We would like to maybe cap that at no more than 10 seconds. So that's what the next parameter is in this ThrowPropsPlugin.2 method. So setting a max duration is effectively adjusting the resistance. And so if, for example, this tween was normally going to take 50 seconds, but we're capping it at 10, then it's going to look like it adjusted the resistance to force the tween to only last 10 seconds. So resistance is not set in stone. It's more of a suggestion that it can be influenced by several parameters, including this next one, which is the minimum duration. So in this case, we can say that we want the tween to last at most 10 seconds and at least 0.25 seconds. And then let's check out what things are how things are going to be affected if we apply a max and a min. So let's take this this dot instance, and we'll rename it min, and we're going to use this the x position of this dot to define the minimum value, and then we'll rename this max for the maximum value, and then we'll just adjust our tween accordingly. We'll start out at a velocity of 200. The minimum is going to be that instance of the dot, its x position. Max is going to be max.x. And then let's make sure that these match. So starting out at the same velocity, publish, and we'll see that since it lands within those two, normally they're both the same duration. However, let's adjust so that the minimum is way over here, and we'll publish again. And so now notice that it adjusted the durations. It knew that box 1 was going to need more time to reach that minimum value. And then we can also do the opposite. We can say we'll bring the maximum in there, and then we'll increase the velocity so things are moving quicker. So it should go well beyond the maximum value there. And sure enough, that stops in the correct amount of time. The duration was adjusted. Now that means this tween had to slam on its brakes really fast in order to make that box stop in time. And so the duration, what normally would have taken 8 seconds for that box to reach its endpoint, it got chopped. The duration got chopped down to a little under 2 seconds. And so what if we don't like that effect? What if it's too harsh, and we'd like to give it permission to use some extra time, pad the duration a bit more in order to get a smoother transition? Well, that's what this last parameter is for. And I just plugged in a 4 here. And so, by default it's 1. When it's 0, I'll show you what that looks like. It pretty much slams on the brakes right away. There's the 1.9 second duration. But if we want to say, all right, you can have up to a maximum of 4 extra seconds to smooth things out, then it'll take that. But again, notice that the normal duration with no constraints is going to be 8. So if we give it permission to take up to another 100 seconds, it doesn't force it to be that much longer. It's just giving it permission to take that much if it needs it. So in this case, it goes to the normal duration of 8 and makes things much smoother, which effectively overshoots the max and min. Now the great thing about having this built into a tweening engine is that it gives you total control over sequencing, and you can do all sorts of stuff. Like here I've got a timeline max that's going to repeat once in yo-yo, and I got 2 tweens strung together. And so we could reverse this, we could stop it, we could pause it, resume it, we could jump to any point in the timeline at any time. So documentation is online and in the downloads, and ThrowPropsPlugin is a membership benefit of Club GreenSock for Shockingly Green and corporate members. So if you want to join, just go to greensock.com/club, and I hope you enjoy it.